Hello everyone, I'm Xiao Gang. Now let's start writing code. We can't just paste the code directly to you. If we did, you'd be confused. So we'll finish writing the header file, then write all the implementations, and then connect the two blueprints. That way, you might not get it, so it's better to just watch it yourself. So we'll follow our usual approach. First, let's assume everything here is ready. All the files here have been created, and the logs have been declared. Then here, we start writing our methods. So we definitely have two methods. What are these two methods? They are for starting and stopping our WebSocketServer. Right. So when starting it, we need to pass a parameter, which is the put, and when stopping it, we just stop it directly. Then here, we create these two. This side will return a boolean, directly telling you whether the creation was successful, because the port might be occupied in this case. So we need to give a boolean, okay, at the creation point. We need to first hit this log. We need to include this log here. For convenience, I'll just include all the header files that will be used at once, because this avoids us going back and forth. First, regarding this socket server, we need to include these two header files. This is our module. This module, for the module, we mainly use these two methods to create the server and create the connection. Then, when we need to create the binding delegate, bind it here to receive information. Then, we have this saving. That way off, no problem, right? Then there are some engine-related things here. We'll include them as well. Next is this utility class and the log. The log should be fine. Then here is the server. We call a log manager to avoid it popping up constant. Okay, this means we are about to start the server. So first of all, we need to prepare a pointer here. This pointer, it is a rather special pointer. It is a Unicode pointer. That's it, right? This is our socket server. This pointer points to the instance of our server. So first, this pointer exists and it is available. This proves that we have already started it. Now that we have started it under this condition, then we cannot start it again. We just wait for a false. Then we just print a log. That is to say, we have already started it now. You cannot open it again. Then, because we have a method to close it here. Then, no matter what, before we go to this structure, we must shut down the server to avoid any data or things being left behind, causing us to be unable to properly release the resources. Then shutting down the server is also relatively simple. We will first print a log here. We are going to shut down our WebSocketServer. Then here, if this value is currently running, then we haven't yet implemented this method to check the running status. We need to release it. So let's ignore this part for now. Okay, let's write this later. Let's leave this spot here for now. Okay, if this place is empty, it means we can create it. So to create it, we first need to prepare several delegates. Let's create it like this first. That is our WebSocket. It can be created like this. So we obtain a class like our ModuleManager. Then we load a module like WebSocket. After obtaining this module, we then create this thing. And here we need to make a forward declaration. Yes, because it needs to use the methods inside it. So we make a forward declaration here. Okay, if we can make a forward declaration here, we continue going down. And then at this point, we need to initialize some things. First, we need to prepare a delegate like this. What is this delegate used for? As you can see, this delegate, it is mainly used for flatter filtering. Then we bind this delegate to our functions method. We don't have this method yet, right? We'll write it right away. As for the signature of this method, it is like this. Let's go back to our side. Let's put it at the very bottom. This is a protected method. It is only used for our internal filtering. Okay, then here, its signature is like this. How do you read the signature? Actually, through this interface, you can see it like this. Its signature is this. It has a return value. 2 more parameters need to be input. Then you can see there are some originals here, or things like IP. Then currently, we don't need to do this filtering. We haven't created its implementation yet. Let's put that implementation over here. And then we print a log here, meaning that some information might be coming in here. Then we give this result a default value. We just need 8 to accept this information. We consider this acceptable. You can see this enum has only 2 values, either accept or reject. So if you don't like it sometimes, you can compare the information inside and reject it. That's it, okay? Once the proxy is ready, we definitely need to bind it to 3. Then we can directly bind it through this module. The WebSocket instance we created, okay? This instance has a method like this. It can select this flater callback, okay? If we see it's highlighted in red here, it means we might not have included its pointer. It's called IWebSocketServer. We can check its path. We can directly include it. This can directly include it. Let's go back. It should be missing here. If it's missing, let's include it. It should be a version change. And the previous one. I might have used 5.3 before. Now it's been extracted again. So here, let's include it. That should do it. Next, this thing of ours. It must exist. But generally speaking, it definitely should exist. So it should be here. If it doesn't exist, right? If it doesn't exist, you'll get an error at this step. In practice, what would be the proper way to write it? It would be more appropriate to write it like this. That is, if it doesn't exist, then we directly return false here. Then we release this. Then we print a log here. Let's change this part a bit. It wasn't written like this originally. This step might fail. If this step succeeds, then we will filter this properly. After filtering, we let it init. Here we need to call this init method, and this init method requires a callback. The last bound address, we can leave it blank for now. Just fill it with an empty one. We merely need to bind this. This means once a connection comes, it will return the created widget to you. We need to wrap this through. Then let's write the failure case first. That is, if it fails here, then it proves that our initialization has indeed failed again. So we need to reset it here, then log it. Next, let's prepare the delegate. This delegate is used to receive the widget we created. Let's write it above. Let's put it here. Okay, as for this method, its signature is quite simple. It's just an hi. Such a pointer points to such an object. Okay. This method should be placed at this position. Placed here. Let's follow this order. Okay, let's create it. We'll ignore the content inside for now. Ignore it for now. Okay, so this is our actual client. Matched with this virtual connection. That is, WebSocket is it. Then bind this delegate here. Bind it to this position. Then when we initialize, we pass this delegate in. Then the filtering is done first. It will use the filtered information to judge if there are no issues up to this point. Finally, we just return a true. Okay, good. Return a true. Good. Next, let's write the code to release this WebSocket. First, you definitely need to check whether it is currently running. If it is running, you can just release it. Why can we just release it directly here? Because it is a unique pointer. That is to say, the ownership of the pointer is actually controlled by you. So here we need to give a judgment whether it is currently running this method. This method is relatively simple to write. That is to say, our pointer exists, and this thing is also available. Then we consider our widget to be present. When we want to close it, we just need to release this pointer. Okay, so it should be like this. Basic. In this way, our incoming framework can be set up. Here, we can receive this connection and information. Of course, we actually have one more step to do here. There is still one step to do, but we haven't written it yet. When we close it, we need to notify all of the client connections. We need to release all client connections. Otherwise, the client might not know that your server has already shut down. So here, we also need to send a message. Let's write it down for everyone. We need to notify all clients that the server has exited. We'll just write it here later. Next, we need to process the proxy we prepared. Here we will actually wrap a layer around this light walking WebSocket.